Morning students, in the previous video session we have gone through the angle of friction. Also you have learned how we can move an object easily by pushing or by pulling. So that's what we have discussed in the last class. Let us discuss about this new topic, angle of repose. What is this angle of repose? Actually this angle of repose which gives very much applications in our daily life that we will discuss later. So before going through this example, let us see some of the concept about this angle of repose. So first thing, what is this angle of repose? You know that for that here one inclined plane is kept. Assume that consider an inclined plane is kept. This is an inclined plane. On this inclined plane now I am keeping an object. One object is kept on this inclined plane at an angle theta which is horizontal to this plane, and now it is making an angle theta also. So assume that now this inclined angle is small angle theta. Assume that the angle between this inclined plane is very much smaller, so that what will happen means we know that this object will not slide down. So if we are reducing the inclined plane angle theta, then the object won't move downward direction. So what we have to do means, if we are increasing this theta value little bigger, or we are increasing the value of theta, so what will happen? We know that the object will slide in downward direction. So in which angle this object started to slide in downward direction, that angle value only we are saying angle of repose. So how we can define means, angle of repose is the angle of inclined plane with the horizontal such that an object is placed on it begins to slide. When we are keeping an object on this inclined plane, and in which angle it is moves, it started to slide over this inclined plane, that value, that angle value only we are saying angle of repose. Let us see what are the forces acting on this object. There are various forces in action here. We know that if you are keeping the object on this inclined plane, there is a downward force mg is acting, and there is an upward force which is 90 degree to this surface, 90 degree. So normal force is acting upward direction. So when it is moving downward, we know that this object is moving in the downward direction. When it is moving in the downward direction, opposite there will be frictional force Fx maximum. And we know that this mg is at an angle theta. So this mg also splitting into two components. One is mg cos theta, and another one is mg sin theta. So that now this mg gravitational force mg is resolving into two components, or splitting into two components, mg cos theta and mg sin theta. So what is the use of this mg sin theta and mg cos theta? You know that mg cos theta is a perpendicular component and this mg sin theta is a parallel component. And what is the use of these components? Now you see this mg sin theta, it is a parallel component, and what is the use of means, this will try to move the object in downward direction. So you see the mg sin theta is used to move this object in downward direction through this inclined plane. And what is the use of this mg cos theta means, you see here in the upward direction normal force is acting. So to balance this normal force, there is a downward force mg cos theta is acting. Now these are the forces acting on it, so that we can write the equation from this. So what equation write means, n is equal to what? n is in the upward direction, mg cos theta is equal to in the downward direction. So you can write n is equal to mg cos theta. So n is equal to mg cos theta. We know that maximum frictional force, static friction formula, Fs maximum is equal to mu s n. So you can write this, you can substitute this n value mg cos theta here. So we will get Fx maximum is equal to mu s into mg cos theta. So this you can keep it equation 1. So next equation we can take it this one. Now we have taken this direction, n is equal to mg cos theta. So this is what equation 1 you can keep. And we know that frictional force formula Fx maximum is equal to mu Sn. So instead of n I am using mg cos theta. That is what I have did. So that what we can do is this you can keep equation 2. Now you see this direction, what is happening? So Fx maximum is equal to mg sin theta. That also we can take it from this diagram. This direction Fx maximum is equal to mg sin theta. So that this you can keep equation 3. Now what you have to do means you have to divide equation 2 and 3. So when we are dividing this equation 2 and 3, what we will get? This is equation 2 and this is equation 3. So that Fx maximum is equal to mu s mg cos theta. This is what equation 2. And equation 3 is we are dividing with this Fx maximum, the same equal to only divided by right side is what? Mg sin theta. Now you know this Fx cancel, m cancel, g cancel. So what we will get means 1 is equal to mu s cos theta by sin theta. Now what you can write means we can take this sin theta here. So that what will come? Mu s cos theta equal to sin theta, cross multiplication. So from this mu s is equal to sin theta, we can take this cos theta downward, so cos theta. So that we can write this mu s is equal to tan theta. This is what angle of repose equation. And we know that mu s is equal to tan theta means this is also same as the angle of friction. And you can see again this equation. This is also one of the important question. Angle of repose. You see, first we are considering an object. We are considering an inclined plane, and on that inclined plane, an object is kept. So that if you are keeping with a small angles, that angle the object won't move in the downward direction. So if we are increasing the angle, so that the object start to slide. So after that you have to write about the forces acting on this object. You know that the downward direction mg is acting, upward direction normal force is acting, and this mg is now resolving into two components. Mg cos theta, it is a perpendicular component, and mg sin theta, it is a parallel component. And what is the use of this mg cos theta and mg sin theta? So this mg cos theta is used to balance this normal force, and this mg sin theta, what is the use of it means? It is used to slide this object in downward direction against this static friction. And let us write the equation from this diagram. You see this direction, what n is equal to mg cos theta. So that we can write the static friction formula. Fs maximum is equal to mu Sn, and n means mg cos theta you can put. Now next equation, so that we will get fx maximum is equal to mu s mg cos theta. So next equation we can take it from this direction. So fx maximum is equal to mg sin theta. That is what this equation. Now we are dividing these 2 and 3 equation. So while we are dividing, this side will get cancel fx maximum, and right side what mu s mg cos theta by mg sin theta, and here mm cancel, gg cancel, only mu s cos theta by sin theta will be there equal to 1. Next step we are doing the cross multiplication, so that mu s cos theta is equal to sin theta will come. So from this mu s is equal to what? We can take this cos theta down. So we will get tan theta, and this is what angle of repose, and it is equal to the angle of friction. Now let us see some of the example from our daily life. This is the first example. You know this in English we used to say ant lion. Maybe you have seen nearby your house like this. In Tamil I think Pannanguri. No. I think in Malayalam we used to say Kuriyana. I don't know what about another. So maybe you have seen this diagram. So you can understand by seeing this diagram. Nearby your house you can see like these holes, and inside like this on ant. And sometimes we used to take this out and we used to play when we are in the childhood and all. So and you see, we know that this antlion makes their nest in a way, such a way, when an ant or something will come on this place, we can see that it will slide and move inside, so that these antlions can eat this ant. So this is one of the very good example we can tell. So this antlions making sand trap. This is a trap for its prey. So it is making a trap to catch that insect. So what will happen means, when this insect or some small ant when it is reaching nearby this edge, so what will happen means it will start to slide in the downward direction. So you know that here the antlion is hiding. It will hide and sit in this place. When this insect will come and fall on this angle, this inclined plane, it will slide in the bottom direction, so that it will go and eat. So and this angle is equal to the angle of repose, we can tell, because the object start to slide. The second thing is we know that sliding what we can tell, sliding board, isn't it? We all know about this sliding board. If this angle, this inclined plane angle is what or more, we can see that the kids can slide over this object. So that is what this angle of inclination is making larger. This angle of inclination they are making larger than the angle of repose. So what will happen means, the slider will reach the bottom. This is a slider. Your kid, maybe when you are a kid, you used to play this. So when we are sitting on the slider board, if the angle is more, so what fastly we can reach in the downward direction. So these are the application. You can go through that. Next we can see about the rolling friction. Actually, this rolling friction, you know this, my dear students, can you assume a world without this rolling? Assume that there is no rolling motion. Assume that there is no rolling motion. So if there is no rolling motion, we cannot assume some things can't move also. So you know that this is one of this invention, the invention of a wheel and all which is playing an important role in every human life. I will tell you some of the example, like you know this costage on rolling. or you can tell that rolling on coastays, we can see the airport and all. If we are keeping our luggages and we are placing the luggages on these coastays, we can see that where we are standing there, these luggages will move and come. Also, you know that some of the luggages it is fixed with a rolling wheel. So this rolling wheel invention is one of the very important invention in human civilization. So what happened means, when an object moves on a surface, essentially maybe suppose if you are saying about the table, one table is there on your house. If you want to move it, we will push or pull, so that we can we know that the object will sliding on it. But if you are fixing a wheel on that table, you see, now it will give a motion which is called rolling motion. And you know that some of the suitcases, now airport going time and all, those who are going abroad, maybe your parents, some of your father is in abroad, maybe he is using a luggage bag with a rolling motion wheel. So because of that, we can easily move that object, and in this rolling motion we can see that the point of contact with the surface is always at rest. So when the wheel is rotating time, so we know that wheel on point and the surface which will be always in contact, so that we will feel that that point of contact is at rest. Actually, so what is happening means, this time we can tell that there is no relative motion between the wheel and the surface, so that the frictional force between this wheel and the surface will be very less. But assume that one object is moving without a wheel. So what will happen? So there will be a relative motion between this object and the surface. So if there is a relative motion between the wheel and the surface, so we know that there will be larger frictional force acting on it. So because of this, we feel the object to move. So this all you can see that in this diagram, you see here two object. This is what a rolling motion. With the wheel you are moving this object easily. You see here he is using one finger, so that easily we can move this object. But in this case, you see there is no wheel. So what will happen means, the relative motion between this object and the surface making very harder, so that kinetic friction is in act. So that what will happen, it is difficult to move this object. Now here during this rolling time, or you can tell that in pure rolling, the point of contact with the surface always will not be with the water at rest. And we can tell that during this rolling motion, some force is acting, some force of friction that comes into act when a wheel rolls over. That is what we can tell rolling friction. So rolling friction means, you can define like this: the force of friction that comes into act when a wheel rolls over. This is what a rolling friction definition: the force of friction that comes into act when a wheel rolls over a surface. So you can use this definition. So during this rolling motion, if suppose if you are attaching a wheel on your table, or you are attaching a wheel on your cupboard, and you are trying to move it, that time one force of friction is acting during this rolling motion, or when wheel rolls over the surface. That is what we can tell rolling motion. And this much is enough about this rolling friction. And next, the important thing is, what are the methods to reduce friction? We know that suppose we assume that you are walking. So walking is possible because of the frictional force. Otherwise, we may slip and we may fall. We know that some places this friction is useful and some places this friction is useless. Wherever so this frictional force have negative effect also, positive effect also. That's what I told. Friction, in some place friction is useful for us, and in some place friction is useless for us. We know that sometimes walking is possible because of this frictional force. Assume that there is no frictional force acting, we may fall. And vehicles, we know that some places watery surface road and some small sand surface road and all. We know that we know that we may slip from the vehicle, and we used to fall from the motorbike and all. Easily we used to fall down, because you know this surface, the friction will be very less. So that place friction is needed for us. That is what I said. Some places friction is useful for us, and some places friction is useless. I'll tell you wherever this useless thing, in some of the machine, while it is moving, you know that bad sound, some sound will produce from the big machines from the industries. So that place and all, we can tell that friction is useless. Because of this friction, easily the machines will get machines wheel will get damage when it is rotating. So that there it is useless, we can tell that. And here we can see what are the methods we can reduce the friction. You know that in large big companies and all, some machines are there. In that machines, it is very important to reduce the friction. And we know that in the bicycle, not bicycle also, bicycle wheel, car wheel and motorbike wheel and all, what are inside one bearing will be there. Inside the one bearing will be there, so that it will help to reduce friction. Also, we know that some places we used to apply the oil to reduce the friction, and these are the ways you can see to reduce these frictions. One is lubricants are used, and another one is ball bearings provided. So these are the two ways we can reduce friction. Lubricants, so to reduce kinetic friction, lubricants are used. Also to reduce the friction, what is used? Ball bearings. This is what 2 point is enough. This is one of the important 2-mark question. What are the methods to reduce friction? So you can tell that to reduce the kinetic friction, lubricants are used in the machines, and these ball bearings providing in the vehicles. It is another effective way to reduce this friction. So these are the things today we have gone through. The first thing is angle of repose, and second is about the rolling motion and the rolling friction, and the last thing is about what are the ways to reduce the friction. Okay, so all of you go through this, and here one important question is angle of repose and what are the ways to reduce friction. So all of you go through this. Thank you all. See you.